Okay, students, so today we will be starting with exercise 1.2 of chapter 1 real number class 10. Question number 1, express each number as a product of its prime factor. Very simple question, like 140. First one is 140, so 2 7s are 14, 2 35s are 70. Then it will not go with 3. Next prime number is 5, 5 7s are 35, 7 1 is 7. So 140 can be expressed as 2 raised to the power 2 into 5 raised to the power 1 into 7. Okay, the second part is 156. The second part is 156. In the similar manner, 156 can be expressed as 2 7s are 14, remainder is 1, 2 8 is 16, 2 again, 3s are 6, and remainder is 1, 2 9s are 18. Now 3 1s are 3, 3 3s are 9, and 13 is again a prime factor. So 156 can be written as product of its prime factors as 2 raised to the power 2 into 3 into 13. Similarly, the third part now, third part is 3825. 3825. So 3825 in the similar manner, 3825 in the similar manner. We'll start with 2. It cannot go with 2. 3 1s are 3, 3 2s are 6. Remainder is 2. 3 7 8 2 22, 3 7s are 21, remainder is 1, 3 5s are 15. Now again 3 4s are 12, 3 2s are 6, remainder 1, 3 5s are 15. Now it will not go with 3. 5 8s are 40, remainder is 2, 5 5s are 25. Again 5 1s are 5, 6 7 8 3, 5 7s are 35, and now 17 1s are 17. So 3825 can be expressed as the product of prime factors as 3 raised to the power 2 into 5 raised to the power 2 into 70. Next one is fourth, that is 5005. Again it can be in the form 5005. So first it will not go with 2, neither with 3. Start with 5 1s are 5, 0 0 1, and 7 1s are 7, 8 9 10 3, 7 30, 7 4s are 28, remainder is 2, 7 3s are 21. Now again after 7 next prime number is 11 1s are 11, 11 3s are 33, 13 1s are 13. So the prime factors of 5005 is 5 into 7 into 11 into 13. Okay. Next one, third, fourth, and the fifth one. Yes, fifth part is 7429. So 7429 can be expressed. It cannot go with 2 3 5 7 11 13 17. It will go with 17. 17 4s are 3s are 7s are, then 19 2s are 38, 67 3s are, and 23 is again a prime factor. So we can say that 7429 can be expressed as product of prime as 17 into 19 into 23. That's it. Okay, now question number 2. Find the LCM and SCF of the following pairs of integer and verify LCM into SCF is equal to product of two numbers. The first part, we have to find out the prime factors. 2 1s are 2, 2 3s are 6, and 13 1s are 13, and 91, the factors will be 7, yes, 7 1s are 7, 8 9 2, 7 3s are 21, and 13 1s are 13. So the prime factors of 26 will be 2 into 13, and the prime factors of 91 will be 7 into 13. So the highest common factor will be 13 because the common factor raised to the power its lowest power, and the LCM will be the common factor raised to the power its highest power. Its highest power is also 1 and lowest power also 1 into the non-common factor. So 13 into 14, that is equal to LCM is coming out to be 13 into 14, 4 to the 12, carry 1, 2 and 4 or 1, 5, 13 to 182. So LCM is coming out to be 1. Now in the second part we have to verify the product of LCM and SCF. So LCM into SCF, that is LCM is 182, SCF is 13. If you multiply it, 182 by 13, 3 2 is 6, 3 8 is 24, 2 carry, 3 1 is 3, 4 5. Now 1 3 1 2 is 2, 1 8 is 8, 1 is 1, 6, 4 plus 2 is 6, 8 plus 5, 13 carry 1, 2 3 6 6. So the product of LCM and SCF is 2366. Now the product of numbers. The numbers were 26 into 91. So just multiply. 6 1 is 6, 9 6 is 54. Now 2 1 is 2, 2 9 is 18. So 6, 4 plus 2 6, 8 plus 5, 10 11 12 13, carry 1, 2 3 6 6, that is 2366. So this shows that SCF into LCM is equal to the product of numbers, hence verified. Product of numbers, hence verified. This is what we have to verify. Okay. Similarly, second part we have to do, we have to find out the SCF and LCM of 510 and 92. So again this is 255, 2 to the 4, remainder is 1, 2 5 is 10, remainder is 1, 2 5 is 10, again 3, so it will be 8 to the 24, remainder is 1, 3 5 is 15, 5 1 is 5, 6 7 8 3, 5 7 35, 17 1 is and 92, again 2 4 is 8, remainder is 1, 2 6 is 12, 2 to the 4, 2 3 is 6, 23 1 is 23. So we are getting the factors of 510 as 2 into 3 into 5 into 17, and the factors of 92 as 2 power 2 into 23. So highest common factor is equal to the common factor raised to the power its lowest power. So the lowest power is 1 here, and here the lowest power is 2. Again I am writing here so that if you forget, SCF is the product of common factors raised to the power its lowest power or lowest exponent or lowest degree. Okay. So and in case of LCM, it will be the product of common factors. Common factors are 2 raised to the power is highest power multiplied by the non-common factor, 3 into 5 into 17 into 23. So on multiplication, 4 3 is 12, 12 5 is 60 into 17 into 23, we are getting equals to 23460. LCM we are getting 23460. Now we can calculate the, since we have got the LCM and SCF, we can calculate the product of LCM and SCF. So the product of LCM and SCF will be LCM into SCF, that is 23460 into 2. Product of LCM and SCF is coming out to be 46920. Okay, 46920. And similarly, if we are calculating the product of numbers, that is 510 multiplied by 92. So it is also coming out to be 46,920. So from here we can say that LCM into SCF is equal to product of numbers, hence verified. Okay, hope you have understood. Similarly, in third part, 336 and 54, we have taken out the factors of 336. So it is, I have already done for you. 2 1s are 2, 2 6 are 12, remainder is 1, 2 is 16 in similar manner. So we have got 336 equals to 2 raised to the power 1, 2, 3, 4. 4 into 3 into 7, and 54 is expressed in the form of product of factors as 2 into 3 raised to the power 3. So now the SCF, highest common factor, is equal to the common factor raised to the power its lowest product of common factors. So common factors are 2 and 3. The lowest power 2 is 2 to the power 1, and lowest power of 3 is 3 raised to the power 1. So the SCF will be equal to 6. LCM is the product of factors with their highest power and the non-common factor. So product of common factor 2 and 3. So highest power 2 is 4 into highest power of 3 is 3 into 7. So we are getting it is equal to 2 to the 4 to that is 16 into 3 to the 9 to the 27 into 7 on multiplication. Just to save time, I have done the multiplication already, that is 3024. Now product of LCM and SCF. So product of LCM and SCF, LCM is coming out to be LCM is 3024 into 6, it is coming out to be 18144, and product of numbers, the numbers are 336 and 54. On multiplication we are getting the same value. So we say that LCM into HCF is equal to the product of numbers, hence it is verified. So here we have seen that the product of numbers is always equal to their product of LCM and HCF in case of two numbers. Okay, in question number 3 we are having 3 numbers and we have to find the LCM and HCF with a prime factorization. Here we are specified with the method, we have to apply only prime factorization. Okay, so same 12 we can factorize, we can 2 6 are 12, 2 3 is 6, 3 1 is 3. Then 15 factorize as 3 5 is 15, and 21 can be factorized as 3 7 is 21. Okay, so 12 can be written as 2 raised to the power 2 into 3 raised to the power 1, and 15 can be written as 3 into 5, and 21 can be written as 3 into 7. So the highest common factor will be the product of its common factors. So only one is common, 3, with their lowest power, and LCM is the product of the common factor with their highest power is also 1 only in all the three cases, and multiply by the product of non-common factors. 2 raised to the power 2 into 5 into 7. So 2 to the 4th is a 12, 12 5 is 60, 60 into 70, that is LCM is coming out to be 420. Okay, understood? Now the next part, that is second part, it is 17, 23 and 29. So simply 17, 23 and 29 are all prime numbers. So the this will be factor of 17 will be 17 to 1 only, 23 will be 23 into 1 only, and 29 is equal to 29 into 1. So SCF will be 1 only. Okay, highest common factor. Thus we can conclude from here also that the highest common factor of the prime numbers will be 1. Okay, and these kind of numbers in which the SCF is 1 are called co-prime numbers. Okay, secondly, LCM of will be 17 into 23 into 29, that is coming out to be, it is coming out to be 11339. This is the answer. Similarly, we can do the third part also over here. Third part, that is we have to find the LCM and SCF of 8, 9 and 25. So the 8 prime factorization of 8 will be 2 to the 8, 2 to the 4, 2 and the 2. 9 will be 3 into 3, 3 to the 9, and 25 will be 5 into 5, 5 for the 25, 5 and the 5. So 8 can be written as 2 raised to power 3, 9 can be written as 3 raised to the power 2, 5 can be written as 25 can be written as 5 raised to the power 2. So here also the highest common factor will be 1 only. There is no common factor other than 1. So these three numbers these are also co-prime numbers. And now if we talk about LCM will be the product of the common factor multiplied by the non-common factors. Okay, so it will be product of common factor raised to the power of their highest power. So common factor is 1 only, and multiplied by the non-common factor. 2 to the 4 to the 8, 3 to the 9 into 25. 72 into 25, it is coming out to be 1800. This will be the answer for the third part. Okay, question number 4. SCF of the two numbers is given and the LCM we have to find out. Very simple question. We know that LCM of the two numbers, like here LCM of 306 and 657 will be equal to the product of numbers upon the HCF of the two numbers, that is 306, 657. So simply we can write LCM will be equal to product of numbers, that is 306 into 657 upon HCF, that is 9. So if we simplify it, 9 7s are 63, remainder is 2, 9 3s are 27. So it will be equal to 306 into 73. So just multiply it, 306 into 73. So on multiplication, 306 into 73. So 3 6 are 18, carry 1, or 3 0 1, 3 3 9, 7 6 are 42, 4 carries 7 3 are 21. So it is 8 3 9 10 11 12 13, carry 1, 2 2 2 3 3 8. So LCM is coming out to be 2 2 3 3 8. Okay. Okay, this type of question we have done in the introduction video, the last video. You can see that 6 power n can be expressed as 2 into 3 whole power n. So that is, it can be expressed as 2 power n into 3 power n. So we know that for 0 for any number to end with the digit 0, it must have 2 and 5 as at least one pair of 2 and 5 as factor. Okay, so since 6 power n does not have 5 as the factor, it is having 2 as the factor. Since 2 power n into 3 power n, it is having 2 as the factor and 3 as the factor, but does not have 5 as the factor. Therefore we can say that for any value of n, 6 power n cannot end with digit 0, Okay, understood? Okay, next question number 6. Explain why the following are composite numbers. So here 7 into 11 into 13 plus of 13. So simply we can write 7 into 11 as 77 into 13 plus of 13. It is an arithmetic expression with 2 terms. So we can take 13 as common. It will be 77 plus 1. So that is 13 multiplied by 78. Further, if we factorized 78 can be factorized further. 2 39s are 78, and then 3 times of 13 is 39, 13 over 13. So we are having 13 into 13 into 2 into 3. So clearly we can see that for any number to be a composite number, it must have more than 2 factors. It must have the factor other than 1 in itself. It is having more than 2 factors, or we can also say that is it is having factors other than 1 and the number itself. Therefore it is a composite number. Therefore it is a composite number. Okay, composite numbers are those numbers which are having more than 2 factors. So it is having so many factors. Okay, so it is a composite number. So in the second part, again 7 into 6 into 5 into 4 into 3 into 2 into 1. So we can take 5 as common. So rest number we can multiply. 7 6 are 42 into 4 3 are 12 2 are 24 into 5 plus of 5. So 42 into 24 is 1008 into 5 plus of 5. So 5 we can take as common into 108 plus 1008 plus 1. So we can say 5 into 1009. So clearly the number is having 5 and 1009 as factor other than 1 and the number itself, 1 and the number itself, therefore it is a composite number. It is a composite number. Okay, very simple part. Okay, in question number 7 it is given that there is a circular path. This is a circular path, suppose, and in that circular path Sonia and Ravi, they are driving around a circular path. Suppose this is the starting point and they are starting at the same point. This is the starting point, okay, start point, and they are starting at the same point and at the same amount of time, okay, at say t is equal to 0, and then they go in the same direction. In the same direction they have started, they are going in the same direction like this, okay. And after how many minutes will they meet again at the starting point? They are asking after how many minutes they are meeting again at the starting point, okay. So time taken by Sonia is given 18 minutes per round. Time taken by Sonia 18 minutes. Time taken by Sonia 18 minutes. Time taken by Sonia in one round. It is given 18 minutes. And time taken by Ravi in one round is given 12 minutes. So who is faster? So clearly we can see that Ravi is faster and Sonia is slower. So one who is faster after time t, after time t they meet again at the starting point. They meet again at the starting point. Okay, let us consider that they are meeting again at the starting point after time t. So the number of rounds taken by Ravi and number of rounds taken by Sonia will be different because the time is different. Obviously Ravi will after time t, Ravi will take more number of rounds and the Sonia will take lesser number of rounds. So let's say Ravi takes X rounds and Sonia takes Y rounds after time t. Okay, Ravi is taking X rounds and Sonia is taking Y rounds. So in case of Ravi, that is time taken by Ravi, in case of Ravi, the time taken by Ravi t will be equal to the number of rounds by Ravi. Number of rounds by Ravi is X multiplied by number of the time taken by Ravi in one round, that is 12. So we can say that here t is equal to 12x. Similarly, if we are talking about Sonia, so Sonia, time taken by Sonia will be again t, because we are considering that after time t they are meeting at that point, the time will be same in both the cases, will be equal to the number of rounds by Sonia. Number of rounds by Sonia is y into time taken by Sonia, time per round, that is 18. So which implies that t is equal to 18y. So it is clear, it is evident from here that this time t is the multiple of 12 as well as 18, or we can say that time, it is the common multiple, or in fact the lowest common multiple. This time t will be the lowest common multiple of 12 and 18. Okay, understood? That means we time taken after which both will meet, Sonia and Ravi meet again at starting point will be the LCM of 12 and 18. So we have to simply take out the LCM of 12 and 18. So LCM of 12 will be 2 into 2. If I am taking out the LCM, 2 6 are 12, 2 3 are 6, 3 1 are 3. So that is 2 raised to the power 2 into 3. And if I am taking out the LCM of 18, 2 9 are 18, 3 3 are 9, 3 1 are 3. So 18 will be equal to 2 multiplied by 3 raised to the power 2. So what will be the LCM? So LCM, least common multiple, will be equal to the product of the common factors raised to the power their highest power. 2 raised to power 2 into 3 raised to power 2, 4 into 9, that is LCM is equal to 36 minutes. So we can say that they will meet after 36 minutes. They meet after 36 minutes. Okay, now the solution is over. But if we would like to see that after 36 minutes how many rounds Sonia will take. So Sonia, number of rounds taken by Sonia is taking 18 minutes for one round. So 36 minutes she will take how many rounds? 2 rounds. Okay, and Ravi will take one round in 12 minutes. So in 36 minutes Ravi will take 3 rounds. So clearly Ravi is faster. So Ravi is making more number of rounds taken by Ravi, and Sonia is taking lesser number of rounds because Sonia is slower. Okay, after 36 minutes they will be meeting again at the starting point. That's it. With this we have completed the exercise. Thank you so much, class. God bless you all.